Hello everyone. We're going to learn about matrices today. We're going to learn how to add, subtract, and multiply matrices. First of all, let's go over some vocabulary. A matrix is a rectangular array of numbers enclosed in brackets. Here's an example. A rectangular array of numbers enclosed in brackets. So that's called a matrix. Dimensions of a matrix. Write as m times n and read as m by n. M by n implies that you would have m number of rows and n number of columns. Our example here has 2 rows and 3 columns, so it's a 2 by 3 matrix. The dimensions of this matrix are 2 by 3. Address. The address of an element is given by listing the row number, then the column number. For example, let's find the address of number 5 that is located here. This entry has been located at row 2 and column 2. So I can just list them, row 2, column 2. Or let's talk about the next one, this number 1. This entry is located at row 2 and column 3 I'm sorry. So that's the address of this entry. Next is a scalar. That's a regular number called a scalar that is multiplied on every entry in the matrix. Like here, for example, we have a number 3, that's a regular number, which is going to be multiplied on every entry in the matrix. So for example, this one is going to be 3 times 5, 15, 3 times 1, which is 3, 3 times 2, 6, 3 times 4, 3 times 6, and 3 times 7. So we multiply the scalar by every element in the matrix. Commutative means the order does not matter. For example, if I add 2 plus 3, it's equal to 5. If I add 3 plus 2, again, that's equal to 5. So I can say the addition of numbers is commutative. That means the order does not matter. Let's work on some examples here. We have a matrix here. We want to know what are the dimensions of this matrix. So I just need to know how many rows and how many columns I have here. 2 rows and 3 columns. So this is 2 by 3. What is the address of entry 8? So I want to know the address of this entry. Where is it located? It's located at row 2 and column 3. So that's basically the address of this entry. Next example, we have another matrix here. What are the dimensions of M? I need to know how many rows and how many columns do I have here. 1, 2, 3 rows and 1, 2, 3 columns. So it's 3 by 3. What is the address of the entry? -3. Okay, so that's here. Which row is it located at? It's located at row 2. Which column is located at column 1? What is the entry at M32? That means at the location of row 3 and column 2, what number do we have here? What is the entry at that address? It is equal to 2 because it's located at row 3 and column 2. So if I ask you what is the entry at M, let's say 3 and 3, 1, we can write it as the first number represents the row number, the second one represents the column number. So entry at 3 and 1 is 3 and 1, it's here. It's equal to 4. In the next example, we want to learn how we can add two matrices. For example, we're given these matrices and we want to find A plus C. So we want to add A and C. Before adding two matrices, we need to know that the two matrices can be added only if they have the same dimensions. For example, what are the dimensions of A? 2 by 2. Dimensions of C is again 2 by 2. So that means I am able to add these two matrices. So I'm going to start adding them, A plus C. I'm going to write the matrices 7, 8, negative 2, negative 4, plus 1, 4, 8, and negative 3. So how do I add these? I just need to add the correspondent entries. Like 7 is located at 1 and 1. This number 1 is also located at 1 and 1. So I am going to add these to the corresponding numbers or entries. So I'm going to have one single matrix as the answer. The elements of this matrix are going to be 7 plus 1, 8. 8 plus 4, which is 12. So you are adding the correspondent elements or correspondent entries. Negative 2 is located at row 2, column 1. So I'm going to add it by the number which is located at row 2 and column 1 of the other matrix. So it's going to be negative 2 plus 8, which is 6. Last one, negative 4 and negative 3. It's negative 7. So that's the answer of A plus C here. Next, we want to add A and D. Okay, this is my A and D is here. Am I able to add these two? No, I can't do that because dimension of D is 2. Dimensions of D are 2 by 3. But A is a matrix which is 2 by 2. So I cannot add them. So cannot be added. And next we are going to subtract D by B. Again, for subtraction, we have the same rule. If you want to subtract two matrices, they should have the same dimensions. Now, what is D? D is a 2 by 3 matrix, and B is also a 2 by 3 matrix. So I'm able to subtract them. Now I'm going to subtract A minus B. So I'm going to write them. First one is 0, 4, negative 4, and 7, negative 2, and 3. Then subtract negative 3, 4, 5, 1, negative 1, and 2. We have the similar rule about the addition here in subtraction. That means we are subtracting the correspondent entries. The first one at row 1, column 1 is going to be subtracted by the next one, which is again at row 1, column 1. So 0 minus 3. 0 minus, negative 3. 0 minus negative 3. The next one, 4 and 4. These two are correspondent. So I subtract them, 4 minus 4. Next, negative 4 and 5. Negative 4 minus 5. Again, the next number is 7 is at row 2, column 1. So I subtract another number which is at the same place, row 2, column 1, and that's 1. So 7 minus 1. Negative 2 subtract by -1. It's going to be -2 minus -1. And the last one, 3 minus 2. Now I can evaluate them. 0 minus -3 is +3. 4 minus 4, 0. -4 minus 5, -9. 7 minus 1 is 6. -2 minus -1 is -2 plus 1, which is -1. So this is -1. And 3 minus 2 is 1. And that's my answer. Also here, I want you to pay attention to the commutative property of addition. As we know, the addition of numbers is commutative. That means A plus C, or for example, I gave you the example 2 plus 3 is equal to 3 plus 2. The same is in adding matrices. So if I add A plus C, that is going to be equal to C plus A. That means addition of matrices is commutative. I'm going to write C plus A here to prove that addition in matrices is commutative. So C plus A is going to be 1, 4, 8, -3 plus 7, 8, -2, and -4. So as I add them, 1 plus 7, because we know that we are adding the corresponding entries, 1 plus 7 is 8, 4 plus 8 is 12, 8 plus -2 is 6, and -3 minus 4 is -7. And as we see, this is exactly equal to what we have here. So we prove that A plus C is equal to C plus A. That is commutative property of addition of matrices. But is also subtraction commutative? No, the subtraction is not commutative. Like D minus B is this matrix, but B minus D is not the same as this one. So here I have written for you B minus D. The B matrix is here and D is here, D is here. And if I subtract them, it's going to be -3 minus 0, 4 minus 4, 5 minus -4, and so on. And if I evaluate all these terms, it's going to be -3, -9, -6, 1, and -1. And as you see, they are different from the previous subtraction. So subtraction is not commutative. Next example, we're going to learn about scalar multiplication of matrices. We have 4 different matrices here, and in the first example, we want to find 2a minus c. So that means we are going to multiply a number, scalar number, by matrix A. So 2 multiplied by matrix A, which is 2, -2, 3, 0, and 2, and 1. And then we want to subtract C from this one. So I'm going to write that 1, -2, -2, 5, 0, and 4. So the first thing that I have to do here is to multiply 2 by this matrix. 2 by 2 is 4. 2 by -2 is -4. 2 by 3, 6. 2 by 0, 0. 2 by 2, 4. 2 by 1 is 1. So you multiply this number by every entry in matrix. Now we're going to subtract matrix C here. -2, 5, 0, and 4. We know that in order to subtract the matrices, we just need to subtract the corresponding elements or entries. So that will be equal to 4 minus 1, which is 3. Negative 4 minus 2, it's negative 6. 6 minus 2, 4. 0 minus 5, 0 minus 5 is equal to negative 5. So it's negative 5. 4 minus 0 is 4. And 1 minus 4 is equal to negative 3. So that will be the answer here. Next example, we are working on C plus 2D. So the C matrix is 1, negative 2, negative 2, and 5, 0, and negative 4. And we want to add it by 2 times D. 0, minus 2, 3, 1, negative 5, and 2. Okay, so if I try to evaluate this, first of all, I'm just going to talk about multiplying 2 by D, which is going to be easy. It's going to be 2 times 0, it's 0, 2 times negative 2 is negative 4, 2 times 3 is 6, 2 times 1 is 1, negative 10, and 10. And I want to add it by this matrix 1, negative 2, negative 2, 5, 0, and negative 4. Now, am I able to add these two matrices? No, I can't, because the first matrix is 3 by 2, but the second one is 2 by 3. They don't have the same dimensions, so I'm not even able to add them. So from the first point, I didn't even have to multiply 2 by this, because I know that these two matrices do not have the same dimensions, so I'm not even able to add them. So this one is not able to add. Example number 5 is asking us to solve for the missing variable. So we are adding two matrices here, and we have the answer. We want to find what is this missing variable here. We know that if we want to add two matrices, we need to add the corresponding entries. Like the first one, which is 3, should be added by x, because they both are located at row 1 and column 1. So 3 should be added by x, and the answer should be also at the same location, which is at row 1, column 1. So that should be equal to negative 2. So now I have a simple equation. I want to solve this for x. The only thing that I need to do here is to subtract 3 from both sides, and next I will have x is equal to negative 5. So that's how I solve for the missing variable in a matrix. Now we're going to learn how to multiply two matrices. Notice that matrices A and B can be multiplied only if the number of columns in A equals the number of rows in B. A is the first matrix and B is the second one. I have written that here for you. A is matrix, the first matrix, and B is the second one. If I want to multiply these two matrices, let's consider m by n as the dimensions of A. So this is the number of rows and this is the number of columns for matrix A. And for matrix B, number of rows is n, number of columns is p. So if I want to multiply A by B, the number of the columns in A, the first one, should be equal to the number of the rows in the second one. So these two should be equal to each other. If the insides match, then you are able to multiply the two matrices. Now, as you multiply, the final product is going to have this dimensions m by n. So m by p will be the dimension of the answer matrix. Okay, now we have two matrices here. Matrix A is a 2 by 2 matrix, and matrix B is 2 by 3 matrix. Now, are we able to do these following multiplications? A by B, let's see. A, I'm going to write that here. A is 2 by 2, and B is 2 by 3. Am I able to multiply them? Yes, because the inside numbers are equal to each other. So yes, I can multiply. And what would be the dimensions of the answer matrix? The dimensions of the answer matrix could be a matrix that has the dimensions of the outside dimensions, like 2 by 3. So I'm going to write that here again. So I rewrote the answer here. A and B, they are 2 by 2, 2 by 3. The insides are equal to each other, so we can multiply them. And the outsides are giving me the dimensions of the answer matrix, which is 2 by 3. Now, how about B times A? Well, B is 2 by 3, and A is 2 by 2. Am I able to multiply them? No, because the inside numbers are not equal to each other, so cannot be multiplied. Okay, so let's go to the next example. We have two matrices, B and A, and we want to multiply B times A. First of all, let's see if we are able to multiply them or not. B is 2 by 2. So this is 2 by 2. What is A? That's also 2 by 2. So I'm going to write that here. What are the inside numbers? They are 2 and 2. They are equal, so I am able to multiply them. Now let's see how we can multiply these two matrices. I'm going to use my calculator to multiply them. So I will go to my calculator over here. Second, x minus 1. That gives me matrices. So first of all, I need to add my matrices into my calculator. So I go to edit, and the first one, I'm going to hit enter. Now, the first thing that I need to do here is to give the dimensions of my matrices. Okay, so I'm going to write A as, which is 2 by 2. So this is going to be 2 by 2. Okay, next I need to enter the elements here. I go down and enter 4. Then we have 7. Then we have 8. Enter, and 2. So that's my first matrix, which is A. Next, I need to enter my second matrix, which was B. So that one will be, I'm going to go again to second, x minus 1, and then go down to B. Next, I need to edit the second one. Okay, so I go down B. This one is again 2 by 2. Enter. Now I'm going to enter the numbers that I have inside my matrix. It's -1, enter, 5, 6, and the last one here is -3. So I made my both matrices. Let's go back to the list of our matrices by going second, x negative 1. Okay, so here I have two matrices. I entered the matrices into my calculator. Now I need to multiply them. Now we want to multiply b by a. So I need to multiply them. I go to second x negative 1 again to have the list of the matrices that I have. The first one that I need is b. So I go to number 2 because that's the first thing that I want to multiply. So I just need to enter 2 here and it gives me b. Then I need to multiply that by, again, second x negative 1. The next matrix that I want to write is A, and that's number 1. So I just hit 1 here, and here I have B times A. Then enter, and this will be the answer of my multiplication. 36, 3, 0, and 36. So the answer of B times A is 36, 3, and 0, and 36. So that's how we multiply two matrices using a calculator, and the answer matrix is going to have dimensions of 2 by 2. Like I'm going to take the outside numbers. It's 2 by 2 as you see we have it here. So that was today's lesson. Have a good day.